distant water first. Not a place yet. A horizon. A question. Years begin this way, quietly. With notes, with reading, with doubt. With the patient work of trying to understand what has already been tried and what has not. At the start, there was a problem that looked simple from far away. How do we know when a swimmer is in danger before the moment becomes irreversible? The first months were literature. Papers stacked into categories, sensors, body signals, wireless links, previous monitoring systems, assisted rescue, warning thresholds, machine intelligence, embedded devices. Each article opened one door. Each door led to 3 more. What appeared to be a technical challenge was also a human one. A moving body in water. A signal that weakens, a delay measured in seconds. A life that depends on notice arriving in time. So the research question grew sharper. Could a low-power IEEE framework help monitor swimmers and support drowning prevention? In real aquatic conditions. Not only in controlled diagrams. Not only in ideal laboratory drawings. But in the real world. The gap became clearer. Many systems could sense. Many could transmit. Few could survive the entire chain. Sensing, communication, aggregation, visualization, and timely response. The architecture had to be designed carefully. Physiological sensing at the body. GPS for position. Embedded processing close to the source. LoRa for long-range wireless communication. Petite for lightweight messaging, a Raspberry Pi gateway. Mosquito at the broker. Node-RED for the flow of data into something readable, visible, useful. Nothing there was accidental. Every component had a role, every interface could fail, every message had to travel through the system and arrive intact. The framework became a map of dependencies, sensor to node, node to gateway, gateway to broker, broker to dashboard, dashboard to interpretation. And beneath that map was a quieter idea. That engineering is not only invention, it is coordination. Then came the prototype. Boards on a desk, cables, firmware revisions, reboots, configuration files, serial logs, threshold values tested, changed, tested again. The first version did not behave like the final one. It never does. A sensor would drift. A transmission would arrive late. A GPS fix would wander. A packet would vanish between one point and the next. And each problem taught something specific. Latency was not just a number, it was distance made visible in time. Packet loss was not just an error count. It was a reminder that wireless communication must be earned, not assumed. RSSI did not merely describe strength. It described how the environment was reshaping the message. So the prototype matured through correction, through calibration, through repeated integration, through the stubborn discipline of making separate systems speak to each other. The laboratory made the system measurable. There the uncertain narrowed. Distances could be controlled, variables could be isolated, a GPS behavior could be compared, latency could be recorded, transmission stability could be observed, packet could be counted. The atmosphere was precise, quiet. almost clinical. Numbers replaced guesses, tables replaced impressions, graphs revealed patterns that the eye alone would miss. In that room, the framework became evidence. And yet, the lab was only the beginning. Its order was necessary. Its limits were clear. A swimmer is not a test bench. Water is not a fixed corridor. A real sea does not stay still long enough for theory to feel comfortable. So the work moved outward. From the lab to the shore.
Distant water first, not a place yet, a horizon, a question. Years begin this way, quietly, with notes, with reading, with doubt, with the patient work of trying to understand what has already been tried and what has not. At the start, there was a problem that looked simple from far away. How do we know when a swimmer is in danger? Before the moment becomes irreversible. The first months were literature. Papers stacked into categories. Sensors, body signals, wireless links, previous monitoring systems, assisted rescue, warning thresholds, machine intelligence, embedded devices. Each article opened one door. Each door led to three more. What appeared to be a technical challenge was also a human one. A moving body in water. A signal that weakens. A delay measured in seconds. A life that depends on notice arriving in time. So the research question grew sharper. Could a low-power IoT framework help monitor swimmers and support drowning prevention in real aquatic conditions? Not only in controlled diagrams, not only in ideal laboratory drawings, but in the real world, the gap became clearer. Many systems could sense, many could transmit. Few could survive the entire chain. Sensing, communication, aggregation, visualization, and timely response. The architecture had to be designed carefully. Physiological sensing at the body, GPS for position, embedded processing close to the source, LoRa for long-range wireless communication, RTUT for lightweight messaging, a Raspberry Pi gateway, Mosquito at the broker, Node Red for the flow of data into something readable, visible, useful. Nothing there was accidental. Every component had a role. Every interface could fail. Every message had to travel through the system and arrive intact. The
framework became a map of dependencies. Sensor to node, node to gateway, gateway to broker, broker to dashboard, dashboard to interpretation. And beneath that map was a quieter idea that engineering is not only invention, it is coordination. Then came the prototype. Boards on a desk, cables, firmware revisions, reboots, configuration files, serial logs, threshold values tested, changed, tested again. The first version did not behave like the final one, it never does. A sensor would drift, a transmission would arrive late, a GPS fix would wander, a packet would vanish between one point and the next. And each problem taught something specific. Latency was not just a number. It was distance made visible in time. Packet loss was not just an error count. It was a reminder that wireless communication must be earned, not assumed. RSSI did not merely describe strength, it described how the environment was reshaping the message. So the prototype matured through correction, through calibration, through repeated integration, through the stubborn discipline of making separate systems speak to each other. The laboratory made the system measurable. There, the uncertainty narrowed. Distances could be controlled, variables could be isolated, GPS behavior could be compared, latency could be recorded, transmission stability could be observed, every good pivot could be counted. The atmosphere was precise, quiet, almost clinical. Numbers replaced guesses. Tables replaced impressions, graphs revealed patterns that the eye alone would miss. In that room, the framework became evidence. And yet the lab was only the beginning. Its order was necessary. Its limits were clear. A swimmer is not a test bench. Water is not a fixed corridor. A real sea does not stay still long enough for theory to feel comfortable. So the work moved outward.